My name is Seth Frame, and this is Geography 778 Practicum in GIS Development. I'm here to give you my elevator speech for my project, and I want to start off with a little bit of background. So let's go to a website. I work for a company called Tyler Technologies. It's a software firm. My office specializes in school bus routing. The product that I work on is called Traversa, and it's a web-based software that allows school districts to route school buses. Part of that involves going through the data which we acquire from counties and finding street overpasses and then what we call disconnecting them. That's where we either assign z-values to the street segments or actually move vertices so that the overlying street is not actually connected with the underlying street, so when a school bus is routing down the network, it doesn't try to take a left-hand turn off an overpass. So right now we do this process manually, going through the data visually and finding these overpasses using the aerial or Google Earth. I had an idea that it would be beneficial to us to use machine learning and Python script to actually programmatically identify potential street overpasses that need to be disconnected. So basically what I plan to do is take aerial imagery and then classify it and use that classification to identify actual street overpasses and then give a probability of whether or not it's an overpass, then the user can go check these points and visually assess them. So let's kind of walk through the process that I've hammered out to actually do this maximum likelihood assessment. So here's an aerial imagery. This is in New York. We have a series of roads. We actually have a street segment file. And here's the actual toolbar that I created right now. So there's two buttons. One's a pre-process, one's a run probability analysis. So the user would click the pre-process to input their streets and then the state raster, which I was using NAPE imagery, which I can show you here. So the first step of the process is it identifies all the vertices at the beginning and the end points of the street segments. And then I take those vertices and actually collapse them into a single point if depending on the overlap. And then I went through and queried out greater than or equal to 4 all of these and turned them into these points. So then what I do is I want to create a buffer around these points where I can clip the raster to kind of limit my analysis area because I don't need anything out here. So I could create these clip buffers. And if we scroll in on this one, we can see it's just basically just follows the road as they intersect. So then these buffers will go and clip the raster, and then with that raster we can then go through and do the maximum likelihood classification. So we can look and see here are the classified rasters, and we have 4 different classifications. We have 1 is shadows, 2 are main roads, 3 are minor roads, and 4 are vegetation. So then the idea is to take these classified areas, turn them into polygons, and intersect them with these buffers. And then this actually has some attribute table. We can see there's a breakdown of shadow, main road, minor road, and vegetation. And then this is the end of what the pre-processing would do. It would spit out a layer that has these 4 fields populated with the areas of the various categories. Now the idea then is for the user to go through and look at a small number of these areas and pick out locations that are indeed overpasses. So they would select between 2 and 5 of these areas, and then they can run the probability analysis tool. And this has actually no parameters because it's going to use the clip buffer as the input. And the idea is that it looks at the breakdown of the different categories and then compares them with all the other clipped areas and finding a similar mix of shadow and main road and vegetation. So now the cool thing is that if I get this up and running and as a proof of concept, we can take it further. One thing that I would really like to do is to take it and be able to pull out building footprints from the raster. It's a thing that other companies do. I know it can be done. we should just be doing it ourselves. And then that'll actually give us a better control over where address points are located within parcel data. It's an issue that we have where a lot of county parcel address points are created from the parcel layer, and it's just a point in the middle of the parcel, so it doesn't represent where the actual buildings are. I think this is a good first step to go down that road, but it's also something that would be very, very beneficial for us.